All right, so a student asked about this last time and I got confused, so I wanted to make a video showing how to do it right. It turned out that there was nothing wrong with any of these, but somehow I thought there was something wrong with them before. So first we're going to install the SecML library. And what we're going to do here is a security attack. We're going to modify the data to confuse the machine learning model and see how much effect that has. So here we prepare a data set. And this is just going to be a data set with a couple of categories of dots. So this is just installing. Okay, it's done. That's installing a library. This is going to make 100 training set samples, 100 validation, 100 test set samples, and it's going to make them well, we'll see the graph. There we are. So you see I got red and blue dots, and you can see there's a line like this would catch most of the variation, and you're not going to get all of them perfect because there is some degree of overlap. So that's the data we're going to try and do a classification job on them. So here we'll create and train a model, a support vector machine, which will just draw a straight line to separate them, which looks like it'll be a pretty good way to do this job. So here's a support vector machine model on the original data, and it gets 94% accurate, which would make sense. You can see it's going to be able to get most of them with just a straight line. All right, now we're going to visualize those results. Drawing the decision boundary, and there it is. So it's a little curvier than I expected it to be, but that's what we ended up here. So you can see it drew a nice boundary between them. All right. Actually, I thought the SVM would always be a straight line, but I guess this must be something a little more complicated. Oh, it's using this RBF kernel, which I think is what adds the curvature to it. All right. So that's the model with the unmodified data. And so the point is, the question is, how much would you have to add poison data to this to make the model start failing? This is 94% accurate. Yep. All right. And so we're going to see how much it hurts. So I'm going to move one label. Now, in order to understand how this works, it's good to see how the data looks like. And the data is trx and tr.y for training x and training y. So to understand this in Python, I print just that, tr.x, and then print tr.y. There. That would give me a clue what we're dealing with here. So tr.x is an array of objects that contain 2 parameters each. So this is x and y for each dot. And this is the label, 1 and 0, where 1 is either red or blue and 0 is the other color. So if you wanted to manipulate these labels, the labels are easy to manipulate down here. If you want to understand the x and y, you'll have to have 2 dimensions to go inside there. So we'll play with that as we go ahead. So the first thing we're going to do is change the first label. So this code will, first you make a copy of the training set, call it poisoned, and then you just change y sub 0 to be 0. And you can see here the very first label is 1. So we just change it to 0, and that's it. Now we've made a poison data set with 1 dot that has had its color reversed. That's all. And so we can plot the 2 options here. And so there's, you see right here, this blue dot was red over here. So we took this red dot and turned it blue, and that should have some effect, you would think, because this blue is way inside where the red is. So now, if we perform the training again and see how it compares, you see, it makes no difference at all. So that 1 dot is not enough to throw off the model at all. It remains just as predictive against the test set as it was before. So that's interesting. So now we're going to loop through the first 40 dots and change the red dots to blue. So what this is going to do is read through 40 dots. If it finds a blue dot, it's going to ignore it. But if it finds a red dot with a 1, it's going to change it to a 0. So logically, it'll only change about 20 of them. So let's see how this looks. All right, so now we changed a bunch of the red dots to blue, and you can see this area is all red, but here there's a whole bunch of blue dots in the red. So that would seem like that might be enough to make the model's performance go down. And let's see here. And it is enough to take it from 94% down to 74%, so that makes sense. All right, and so here you're going to just change that to check the first 60 dots and turn the red dots blue. So that's pretty easy, and in order to do that, I would just go up here and change this loop. Where's the loop? There's the loop. Change this to 60 and let it go. And now there are hardly any red dots left at all, like only one here and that one's gone. And if you compare it to my image here, oh, I didn't give the image, but anyway, that'll get that one. And then the next one is the one that buffaloed us last time to reverse the colors of the first 40 dots. But that's really not so hard. So if you go back to here, this is the one that was modifying the first 40 dots. I'm going to change it to 40 dots. Okay, and now, if it was 1, change it to 0. So all I have to do is now say otherwise, which is, okay, else, then I change it to 1. There. That should be all I have to do. This will change the 1s to 0s and the others to 1, the others being 0. That should do it. So this one here, you see it was mostly blue, and there's only one red dot down here. But now if I run this one, it gets a bunch of red dots down here. So this really changes some of these colors and some of these, so that pretty much fouls it up, and that's what I wanted to see. And if you look at the example here, you can see that's what happens. A bunch of red dots in the blue dots, and a bunch of blue dots appear in the red dots. That's what you expect. And this one here was also interesting, where you want to just take the red dots over here and change them all blue. So you're going to have to read the x coordinates. So that gets a little bit tricky with the Python, and let me show you how to do that. So I want to change red dots blue. Now, let's start from this code here, which changed the red dots to blue of the first 40 dots. So I'm going to erase this old code and put in that code. Start from here. So this is going to go through the first 40 dots and change the ones that are red in the first 40 to blue. Now what you want to do, instead of it, we're going to go through all 100 images here, and we're going to not use, if they're red, turn them to blue. We're going to want to change them if they are greater than 0.8 in this dimension. So to understand that, let's track down how to see that dimension. And so that will be, let me just put a block of code. I'll just take this block of code here and delete it. Okay, so I'm going to start out by printing tr.x. We've done this before. That's these arrays. So now I want to figure out how to get inside there. See 2 square brackets here. It's an array of arrays. So I think if I do trx0, that should just be the first dot. And it isn't. So I think it might be 0, 0. Takes me a couple tries to get these things right. There we are. So 0, 0 gives me 0.56. Now let's print trx also so I can compare it. So I just want to copy that line and put it here. And up here I just want to print the whole trx. There, now I can see what's going on. So here's the whole trx, 0.56, 0.87. And the first number is 0.56. So the 0.56 is this dimension, and the 0.87 is that dimension. So there is this 0, 0, Okay, now I want to continue to see it's either the first number, so one of these only goes from 0 to 1, and that's determining which axis you're in, and the other goes from 0 to 100. So let's just see which way it is by a simple brute force technique. Let's try printing TRX 10, 0. Let's see what that does. It'll be an error if that's the first index is the dimensions, and it won't be an error otherwise, and it looks like it's not an error. That's really a 10th point. Okay, so this is the first index is the point. The second index is the one that determines whether you're looking at the x or the y. So now I know what I'm doing. I want here, I want if TRX, okay, x sub I comma 0. There. If that's greater than 0.8. Then I'm in these dots over here, and I want to turn them all from red to blue, which is changing from 1 to 0. So now this is it. If train positioning xi comma 0 is greater than 8, then make it 0. That should do it. Let's see if that does it. And it did do it. See, everything's the same except this stripe over here. The reds have all changed to blue. So that's what I wanted to show you. That'll get you the right start. And it takes a little bit of work to figure out how to dig into the arrays here. But anyway, that's what I wanted to show you. So I'll stop